Alright, so some of you may or may not know that I'm actually studying to be an electrical engineer. And when I was learning this, I really couldn't find that many resources that I was, of specific things I was looking for. And this is one of the things that I really wanted to find, but I couldn't. Not really. So I'm making this to help other people who are studying this. Anyway, so we're gonna find an expression for v of t for t greater than or equal to 0. Alright, so let me go ahead and just start making this circuit now. Alright, so that's a mistake. And I'm just not putting any units here. Okay, now this is the circuit. So we need to look at the t equals 0 case, t equals 0 minus case, and t equals 0 plus case. So we're looking at before switching and after switching. Okay, mistake. Now, at t equals 0 minus, it's going to be on the 10 volt source. And the inductor is going to act like a short circuit, and the capacitor is going to act like an open circuit. Now, capacitors, their voltage don't jump between switching because they have to conserve the energy. Now, we're going to try to also find, the current of the inductor at t equals 0 because it also doesn't jump, the current doesn't jump, or the voltage can jump. Alright, so we're going to use voltage division to find v of 0. So we have this is 6 ohms. So we have 10 times 6 over 4 plus 6, which is 10. So that means this is just going to be 6 volts. Okay, now let's also find the current of the inductor. So this is going to do the KVL here. Let's just call this loop 2. So we're going to have a minus 10 plus 4IL plus 6IL, so it's going to be plus 10IL equals 0. This means IL is going to be 1 amp. Alright, so now that we have that, we can look at the t equals 0 plus case. So at t equals 0 plus, the unit step function is just always going to be 1, so we can just omit it here. So just 6e to the negative 3t. That's what we have here. Plus minus. Okay. Oh my god. Okay. Okay, so now this capacitor and this whole branch are parallel, so that means they have to share the same voltage. And we know the 1 amp is still flowing through this branch due to the inductor, So we have 1 amp going through this resistor, 6 ohm resistor here. And we know through Ohm's law that means you have to have 6 volts, V equals IR. But if that's 6 volts, that means the voltage of the inductor is 0 volts at time equals 0 anyway. Alright, so that's just some important information to keep in mind. So this is just 0 volts right now. Okay, now we just need to find the current of the capacitor. Then we have all the initial conditions we need. Then we can actually start doing the ODE. So let's just do some node analysis here. And we're also going to use the node analysis for the ODE. Anyway, so we have 1 amp flowing down this branch. We have well, we know this is 6 volts, right? So we don't know the thing of the capacitor, so let's just say this is IC. And then this is just going to be 6 volts minus, at time equals 0, this is just 6 volts. So minus 6 over 4 equals 0. So that whole term just goes to 0. So that means IC is just going to be negative 1 amp. But we know that IC is just going to be 1/4 dV dt. So that means the VDT at 0 is just going to be negative 4. Alright, so now we know that, now we can actually just do the ODE now. Now we have to write this in terms of functions. So we're also going to use this loop. I'm going to call it, oh, the wrong way. I like to go in the same direction as the current. So let's go this way. Let's just call this loop 1. Alright, now, so using the KCL, we have the inductor current, so that's IL. Then we have the current of the capacitor, so that's going to be 1/4. And instead of using DDT, I'm just going to use S. So that I'm putting in operator form. So that's just going to be, 1/4 SV. Then we have the other, so that's going to be V minus 6 e to the negative 3t over 4 equals 0. So that's 1, let's say this is equation 1. Now we also have equation 2 here, so we're going to use this loop. So we're going to have minus V plus, so the inductor current is going to be, the voltage of the inductor is going to be L didt. L is just 1 in this case, so it's going to be, since I'm using that, it's going to be SIL plus 6IL equals 0. Alright, and this is equation 2. So now we're going to use equation 1. We're going to solve for IL, and then take the derivative, and then we're going to plug that into equation 2. So let's just reorganize equation 1 here. So we have IL is going to be equal to 6 e to the negative 3t over 4. I need to go down a little bit more. Minus V over 4 minus 1/4 SV. Now, let's take the derivative of that. So we're going to get SIL is going to be equal to, I'm just going to take the derivative of that instead of using S. So we're going to have negative 18 e to the negative 3t over 4 minus SV over 4 minus 1/4 S squared V. So now we have those two things. Now we're going to plug these into equation 2 here. So we're going to have a minus V still, plus SIL is going to be, okay, let's get rid of that plus. So it's going to be minus 18 over 4 e to the negative 3t minus SV over 4 minus 1/4 S squared V. Then we have the 6IL to deal with. So that's going to be plus 36 e to the negative 3t over 4 minus 6v over 4 minus 6v, vs over 4. And that's still going to be equal to 0. Now we just combine like terms and solve the ODE. So we end up with, let's first actually, I guess it don't matter. So we have this 36 and this minus 18. So we end up with a positive 18. So I'm going to write this equation over here. And then let's move it to the other side. So that becomes a negative 18 over, oh my god, negative 18 over 4 e to the negative 3t. Now we have an SV and a 6 SV. That becomes a 7 SV. So we have a minus 7 SV on this side. Okay. And then we have just a, oh, sorry, that's over 4. Minus 7/4. I was just looking at the numerator when I was adding. Anyway, then we have a minus 1/4 S squared V. And then lastly, our V. So we have a 6/4 here and a 1 here. So that becomes a 10/4. So it becomes a minus 10 VS over 4. Now we have this. Let me put a line here so we can differentiate this not being part of the other stuff. Now we just solve the ODE. So we can multiply everything by negative 4. So you end up with S squared V plus 7 VS. Wait, hold on. Sorry. Wait a minute. That S is not supposed to be there with the 10. Plus 10 equals 18 e to the negative 3t. Okay, so now we have this equation. So to solve the ODE, so this is non-homogeneous, right? We need to write the homogeneous version. So we end up with S squared V plus 7 SV plus 10 equals 0. So that's the homogeneous answer, equation. Now we are going to just keep going here. So I like to use R for my characteristic variable. So we write the characteristic equation. So we end up with R squared plus 7R plus 10. There's supposed to be a V here. Plus 10 equals 0. Okay. Now, we can just use the quadratic equation. So we end up with R being equal to negative 7 plus or minus the square root of 49 minus 40 all over 2. So that just becomes 9 in the root. Root of 9 is 3. So negative 7 plus 3. That would become negative 4. Negative 4 over 2 is negative 2. So we have negative 2. And then what's the other one? So now we have the minus 3. So that becomes a 10. And then 10 over 2. So that becomes a negative 5. Okay. So now that we have those two roots, that means the homogeneous version, V, the homogeneous answer, so V sub H of T, is going to be, let's just say A, e to the negative 2t, plus B, e to the negative 5t. Okay, now we need to do the particular solution. So For this, I'm gonna do it both. I'm gonna do it two different ways. The first way I'm gonna do it is I'm gonna use variation of parameters, and I mean undetermined coefficient is way easier for this problem, but it's good to practice under variation parameters because it is more applicable to more functions. You can only use undetermined coefficients with specific functions, so getting more familiar with variation parameters is good. It helps. It's going to help help a lot later on. Anyway, so with variation of parameters, you assume the particular solution is of the form mu1 e to the negative 2t plus mu2 e to the negative 5t. All right, now we'll define mu1. All right, so we first make these two assumptions. So we assume that mu1 prime, and let's just say this is y1. I'm just going to write it. So we have e to the negative 2t plus mu2 prime e to the negative 5t. We assume that's equal to 0, and then we assume, I mean, this is like how you solve. It's the core assumptions that you have to make to use variation of parameters. And so we have negative 2 mu1 prime e to the negative 2t minus 5 mu2 prime e to the negative 5t equals the forcing function. In this case, is 18 e to the negative, what was it? 3t. And now we just use Cramer's rule here. So let me first take the Wronskian here because we're going to need it. So the Wronskian is going to be the determinant of this matrix. So it's going to be e to the negative 2t, and that's going to be negative 2 e to the negative 2t, and then we have e to the negative 5t, then we have negative 5 e to the negative 5t. Alright, so now we have negative 5 e to the negative 7t plus 2 e to the negative 7t. Alright, so this sum is going to result in negative 3 e to the negative 7t. Alright, so now we have the Wronskian. So now we need to use Cramer's rule because the denominator is just going to be the Wronskian, so we don't have to worry about computing it every single time. Now, to solve the ODE, we use the Cramer's rule. So mu1 prime is going to be equal to the determinant of this matrix. So we have 0, 18 e to the negative 3t, and then we're going to have e to the negative 5t, and then negative 5 e to the negative 5t, and over the Wronskian, so that's just negative 3 e to the negative 7t. Alright, so we end up with a negative 18 e to the negative 8t over negative 3 e to the negative 7t. Okay, so these negative signs cancel. 18 divided by 3 is 6, so we end up with 6 e. So we're going to add that, so that would just be e to the negative t. And now we just integrate that to get mu1 prime. To get mu1. So mu1 is going to be integral of 6 e to the negative t dt. So we end up with a negative 6 e to the negative t. Alright, so that's the first thing. Now we do the same thing with mu2. So mu2 prime is going to be equal to the determinant of this matrix. So we're going to have e to the negative 2t, negative 2 e to the negative 2t. Then we're going to have 0, 18 e to the negative 3t, all over the Wronskian, which is negative 3 e to the negative 7t. Okay, so now we end up with 18 e to the negative 5t, okay, all over negative 3 e to the negative 7t. Okay. Now, again, 18 divided by 3 is 6. This time it's going to be a negative 6. So we have a negative 6 e to the 2t, positive 2t. Okay, and then that means mu 2 is going to be the integral of 6 e to the 2t dt. So that's just going to be 3 e to the 2t. All right, so now, and don't forget the negative sign. It's supposed to be a negative 6. So it's negative 3. All right, so now we have those two things. Now we just go and plug them back in, because remember, we assumed the particular solution was mu1 times that. Where is my particular? Okay, yeah, so here. So mu, okay, so I said e to negative 2t. Okay, so that means the particular solution via p of t is going to be mu1 negative 6 times, so e to the t, negative t times e to the negative 2t. So that's negative 6 e to the negative 3t plus mu2 prime, mu 2 times e to the negative 5t. So we just have a minus 3 e to the negative 3t. So they end up as negative 9 e to the negative 3t. So now we have that particular solution, and now we have to add it with our homogeneous solution to get v of t is just going to be a e to the negative 2t plus b e to the negative 5t minus 9 e to the negative 3t. All right, so now just to solve for these undetermined coefficients, to solve for these coefficients, we just use the initial conditions. So we know v of 0 is 6. So 6 is going to be a plus b minus 9. So a plus b equals 15. And then now we take the derivative. So we have dv is going to be negative 2a e to the negative 2t minus 5b e to the negative 5t plus 27 e to the negative 3t. And that was equal to negative 4. Wait, did we actually solve for that? Because I remember we did the, we found the current was negative 1. Yeah, we did. Okay, negative 4. Good. Just making sure we put that in there. Anyway, so yeah, so we know that's equal to negative 4. So we have a negative 4 going to be equal to negative 2a minus 5b plus 27. So we subtract the 27 over, and we get 31. So we have a negative 31. So we have a, I'm just going to write it under here. So we have a minus 2a minus 5b equals negative 31. So now we have these two equations. You can use Cramer's rule. You can substitute. I think I'm just going to substitute this time. I think I used Cramer's rule before when I did this, but substitution just looks nicer right now. Okay, so I'm going to multiply the top equation by 2. So we have 2a plus 2b equals 30. Then we have a minus 2a minus 5b equals minus 31. And now I'm going to add these two equations together. So I'm cancel that. So we end up with a minus 3b equals negative 1. So b equals a third. And now that we know what b is equal to, we can just plug that back into the first equation and get an expression for a. So we plug in a third for b, and we move it over. So 15 minus a third is going to be, hold on, let's just go ahead and multiply that by 3. I'm just going to leave it as a mixed number because I don't want to leave it as a decimal. So we're going to have 45 thirds minus 1/3, that's 44 thirds. So a is 44 thirds. And there we go. So that means our final answer is v of t is going to be 44 thirds e to the negative 2t plus 1/3 e to the negative 5t minus 9 e to the negative 3t. Catch. Okay. Now let's go back and do it with undetermined coefficients, and you'll see you get the same answer. So way up here, we had we did it this way, but now with undetermined coefficients, you just assume the particular solution is of the same form. So you assume v sub p is going to be equal to, let's say, c e to the negative 3t. All right. So now let's take the derivative of this. So we have dv sub p dt. It's going to be negative 3 e to the negative 3t. And don't forget the c. And then the second derivative, d squared v sub p dt squared, is going to be equal to 9c e to the negative 3t. All right, now we have to plug that back into our original expression. So where's that at? The non-homogeneous. Okay, here it is. Zoom out a little bit. So this is our non-homogeneous equation. So we're going to plug in. So we have 9c e to the negative 3t plus 7 times that, which would not be a plus at that point. So that would be a minus 21c e to the negative 3t. Then finally, we end up with a 10 times v, so that's just going to be plus 10c e to the negative 3t equals 18 e to the negative 3t. All right, so now we just combine like terms. So 21 plus negative 21 plus 10, that's negative 11, and then 11 minus 9, that's 2. So we have a negative 2c is going to be equal to 18. So that means c is going to be equal to negative 9. All right, so now that we have that, we just end up doing the same thing over again. So we have the v sub t is just going to be a e to the negative 2t plus b e to the negative 5t minus 9 e to the negative 3t. And then we just use the initial conditions and we get the same thing. So I hope you guys enjoyed this video. I hope it was helpful for y'all. Let me share the final answer again for y'all in case y'all are still working on it. And yeah, so let me know if you have any questions. I'll answer them in the comments if I can. But anyway, thanks for watching.